In this video, we are going to discuss that how can the general equation of second degree represent the equation of a circle. Now, the first important question is that what is the general equation of second degree? So, the general equation of second degree with two variables is ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equal to 0. Now, how can you obtain this equation? Because if you know that the general equation of the first degree is ax plus by plus c equal to 0 definitely, and if I have a1, b1, c1, so a2x plus b2y plus c2 equal to 0. So if these two are the general equation of 1 degree, or you can say these are the standard straight line equation, if you multiply these two, you are going to get something of this form. So since we are not going to discuss about this one, we are going to discuss directly this one. So now, under what condition this general equation of second degree will become circle is that a should be equal to b, means the coefficient of a should be equal to coefficient of b, and in that condition only, suppose if a is equal to b and you divide both equation either by a or by b, then this equation will become x square plus y square plus 2h by b or a, whatever you choose, plus 2gx upon a plus 2fy upon a plus c upon a equal to 0. And this equation can be written, but now you pay attention to it. We are ignoring this term 2hxy. So the required condition is that a should be equal to b, and at the same time ampersand, right, and h should be equal to 0. So if a is equal to b and h is equal to 0, then the general equation of the second degree represent this one, and this can anyhow by manipulation be written in the form of x minus g whole square plus y minus f whole square equal to r square. So this will represent the circle. Okay, so now here we are done for this part. In the next part, we are going to discuss about how to find the equation of a circle when the coordinate of the extremities of the diameter are given. So back to the business, and here we have a circle, and now suppose if the coordinate of extremities of the diameter, this is circle center, so a and b are the extremities of the diameter, because AB is the diameter. So if they have the coordinate x1 y1 and this one have the coordinate x2 y2, we assume our moving point whose locus we are trying to find is here hk. So just join. And in class 10 you might have studied in property of circle that the angle in a semicircle is right angle. So angle in a semicircle is right angle means PB is perpendicular to PA. So PB is perpendicular to PA. Now if you know that in a straight line, you might have studied in class 10 that if two lines are perpendicular, the products of their slopes is equal to -1. So what is the slope of the line PA here? So I write M PA. Slope is given as y2 minus y1 upon x2 minus x1. So we'll have k minus y 1 over h minus x1, and the slope of PB is k minus y2 upon k minus x2. So since they are perpendicular, so MPA into MPB is equal to, this is M minus 1. Therefore we'll get k minus y1 over h minus x1 into k minus y2 over k minus x2 equal to minus 1. So this will become k minus y1 k minus y2 equal to minus, sorry, this one should be h, sorry, here this is h because this is, yes, okay, so h minus x1 h minus x2. If you transpose this on this side, this will become h minus x1 h minus x2 plus k minus y1 k minus y2 is equal to 0. Now replace h by x and k by y. You will get x minus x1 x minus x2 plus y minus y1 y minus y2. This is the equation of the circle with the diameter is known. So equation of circle, if coordinates of extremities of diameter, extremities means is the end point, the coordinates of the end points of the diameter are known. So the equation will be x minus x1 x minus x2 plus y minus y1 y minus y2 equal to 0. So I hope this idea is clear. So in the next section we are going to explore another property of the circle. So just now, so you have got some ideas about the circle. So the general form of the circle, standard form is also called standard form of the circle, is always written as standard form. Is x square plus y square plus 2gx plus 2fy plus c equal to 0. Now just assume this is a case. This is my circle, and if this circle cuts the intercepts like this, okay, then how will you find this coordinate and how will you find this coordinate? So it is just like, this is the equation of y-axis is x equal to 0, this is equation of y-axis, that is x equal to 0, and equation of x-axis is y equal to 0. So if you put the value x equal to 0, means this one. So you are trying to find out the points where this line will meet. So suppose if I say that x equal to 0, then what I get? I get y square plus 2fy plus c equal to 0. Now this is a quadratic equation in y, and here we'll get the 2 points, one here and one here. Then suppose if you know that this is the coordinate of this one, it can be, suppose if I call it as y1, so this will become 0 y1 and this will become 0 y2, and then the length of this segment will definitely be y2 minus y1, or if you just say this is y1 and this is y2, so this can be y2 plus y1 depending on how you take them. So here I call from here to here this is y1, from here to here this is y2. So if I want to find the distance between here to here, so this is y1 and this is y2. So what I need to find? y1 plus y2. So how will you do that? So this is the quadratic equation, and you know that if the quadratic equation always have the two roots y1 and y2, so if you take let y1 and y2 are the roots of the quadratic equation, those who have studied the quadratic equation, they know that the y1 plus y2 sum of the roots of this quadratic equation is minus the coefficient of the middle term upon the coefficient of y square, that is 1. So this is minus 2f, and the product of these two roots is simply c. Now we have the y1 plus y2, we can directly find minus 2c, and if you have y1 y2 c, and suppose if anyhow if these 2 points do not come, like the circle is section goes like this, and then circle cuts this like this, then in this condition you have to find this line segment. So one point is the vertex here 0, so and this is another point. So this line segment can be found out using y2 minus y1, and that y2 minus y1 whole square will be y2 plus y1 whole square minus 4 y1 y2. So this will become 4f square, because y1 plus y2 is minus 2c and this is minus c. So y2 minus y1 will be like this. So you can find this line segment, and this is y2 minus y1 4f square minus c. And if you want to find out this line segment, then you have to put, because the equation of the x-axis is y equal to 0, and this is intersection, this point and this point are intersection points of these two line segments. So we say that here in this equation we are going to put y as 0, so it will become x square plus 2gx plus c equal to 0. Again, this is a quadratic equation, and if this is a quadratic equation, definitely it will have the two roots. As if I say the say x1 and x2, then sum of the roots x1 plus x2 will be minus 2g, and x1 x2 equal to c. So in this condition, this section you can find, suppose I do not know what it is right now because this is y. Suppose if I say it's 0 comma y1, so this is 0 comma 0. So this equation looks like after solving one value of y is coming to be 0, because this x-axis 2 points at the end, this is the origin, so we know that this is coordinate is 0 0. So this coordinate we suppose 0 comma x2. So here x1 is again 0. So instead of finding this one, we can find it. But I am saying, suppose if it is not this one, suppose it goes like this. You do not know what it's going to look like. If it looks like this, suppose this is x1 and this is x2, because this is on x-axis is x1 0 and x2 0. In this condition, this line segment will become x2 minus x1. The same way again you can find x2 minus x1 as under root 4g square minus c. This is all about the section. Okay, so now in this we are continuing the same way. Now we are trying to find out some different situations, what happens if. So this equation again I mentioned is called the standard form of circle, and that represents x square plus y square plus 2z plus 2fy plus c equal to 0, and then here this same circle will have the center at minus g minus f, and its radius will be under root g square plus f square minus. So these two are the important parameters of this circle. Now just assume case number 1 where the circle is touching the x-axis, means x-axis is tangent to the circle. So this is my origin, this is x and this is y. So now this coordinate, this is minus g comma minus f. Now if from here if I drop a perpendicular, then here you see that minus g will be from this point to this point, but if I drop a perpendicular here, this point is minus f. So now you can see that we can directly conclude that this is the case where the radius of the circle is just minus f. So since radius is not related to minus or plus, it is just a magnitude, so we can say r is equal to minus f, or r is equal to f. So in this condition you directly get a situation that r is equal to f. So how do you solve this equation? Just put r equal to f. Now if you put r equal to f, then what relation you derive from here? That since r is under root g square plus f square minus c, so if this is minus f square is g square plus f square minus c, then f square these two cancel, and then you get c equal to g square, right? So here in this condition you can find the equation of the circle will be x square plus y square plus 2gx plus 2fy plus g square equal to 0. Suppose if I forget everything, I don't remember what is circle, what is this, I just simply go by the definition, then my circle is going to be in this condition that distance, suppose if I take this my point as locus hk, so I get h plus g whole square plus k plus f whole square, k plus f whole square, and the radius that is f square. So now you see that the f square from this will cancel the f square for this, then what you get? H square plus 2gx I write here, and g square again I write here, and then I write k square here plus 2kf we can write here plus f square is 0. So now again you see that we are getting this 0 is here, f square, so these two cancel each other, so we are getting x square plus y square plus 2 gx plus 2 fy plus z square equal to 0. Now check it out, these two equation, x square plus y square plus 2zx plus 2fy plus z square, x square plus y square plus 2zx plus 2fy plus z square is equal to 0. Different authors explain the same thing in a different way, that is their prerogative. I don't want to go into those detailings, but I am trying to say that if you just follow the basic definition, then you can have your own set of values, and which is going to define the nature of the circle. So in the very next video, not next video, like in the very next part, we'll discuss about some other special cases.